What's up, party people? We're at it again, and we are working through our Unit 5 lesson workbook or whatever. So, in this particular lesson, we're on lesson 11, right? And so, we're going to go through actually Bridge 1, Bridge 3, Activity 1, and Activity 2 for this particular um, lesson. I'm going to share my screen. Remember, students, if you're watching this, like, share, and subscribe to Young Gurus Math Tutoring. Right now, I've just been doing these lessons for our classwork, but at the same time, I'm gonna be bringing out some other stuff. I got a lot of stuff for those of you that may be looking for information or videos to teach you information from previous grade levels, or even those of you that want to take it a step further and go into information for the higher grade levels. I definitely encourage you to check out those videos. I've been doing this for a few years. Um, but so there's hundreds of videos on this channel that you can look at to help you out. But let's get into it. This one, I'm going to put them all together again, most likely. And we are on page 113, looking at the bridge. So notice the lesson is about sketching the graphs of functions. So we start out with just a little bit of review on slope, and we want to match these slopes with one of these lines. So the simplest way that I teach on how to calculate slope when you're already given the graph, notice the line, excuse me, is here, but the slope is really like a triangle, right? So we're going to go, we can do this. If we go here, let's go down. So we start there. So 0. So 1, 2, 3, and then 1, 2, right? So rise over run. Notice it's a positive slope because it rises from left to right. All right, so the rise is 3, the run is 2. And so here for the slope of A, we have 3 over 2. When I look at B, let's do this one the other way. We don't have to necessarily trace the triangle. We could, but we don't have to. Let's say this triangle wasn't there. We can still go from this original point up, and we can go up. So we start there, 0, 1, 2, and then we go over the run, 1, 2, 3, 4, 5, 6. All right. So notice this is rise of 2, a run of 3, and so, I'm sorry, I said 2 over 3. I am tripping. 2 over 6. All right. So 2 over 6. I keep simplifying it. I'm sorry, y'all. 2 over 6, which that can simplify to 1/3. All right. So we've knocked out the 1/3. We've knocked out the 3 over 2. And then here we go here. So once again, let's do the rise. So if I start here, so 1, 2, 3, 4, 5. And then if I start here, 1, 2, 3, 4, 5. So 5 over 5, which that gives us 1. Here, these two. So now we want to pick 2 points that intersect with the grid lines. Okay, so here I choose that one. And let's say we choose this one. We could choose that one. We could choose that one. We could choose that one. Any of those. So I'm going to start from this lowest one, and I'm going to say up 1, 2, and then over 1. So the rise is 2. The run is 1. So 2 over 1 is simply 2. All right. Last but not least, we want to select a point where the line is on where grid lines intersect. We select another point right there. So if I go up 1, and then I go over 1, 2, 3, 4, and we're back on the line. Okay, so 1/4. Notice there's only one of these that represents 1/4, so 0.25. So we're left with 1/2, right? And we want to draw a line that has a slope of 1/2. So let's just pick a point here, and I go up 1 over 2, boom, up 1 over 2, up 1 over 2, up 1 over 2. And then now I can draw a line to connect those. Where's my line? Hold up. So I don't know why I'm not finding my lines right now. Oh, wait, hold up. Yeah, I am. So here, let's change the color of this. Let's change it to blue. Well, then now let's do black like the rest of them. So then, boom, start here. I'll go through all those points and boom. All right. And we can double check this if we want to. Uh-oh, nope, that's not what I meant to pick. We can double check this if we want to. Let's change the color. So if I started this one right here, I'll go up 1, and I'll go over 1, 2. So rise 1, run 2. So it has a slope of 1/2. All right. Just a little refresher for you. Let's clear this out. Let's clear this out. And then we're gonna go to the next slide. Let's boom. So bridge 3. So boom. Let's share this. Boom. Now this one, I like this activity because it makes you think a lot, right? And so it looks like you may be looking at this like, what is this? The graph of a flag or something like that? And it does look like that, but let's answer these questions. So it says Priya is running once around the track. The graph shows her time given how far she is from the starting point. Now, the key thing here is knowing she's running around a track. And so a track, that is not what a track looks like right there. So I'm not going to try to draw this perfect, but it looks something like that. It's like an oval shape, right? So let's just say this is the starting point here. Doesn't matter where the starting point is, right? But notice it says the graph shows her time given how far she is from the starting point. So far, which is distance, time, okay, which is so distance and that's meters. All right. And then time is in seconds. Okay. Notice they have distance on the independent axis this time, on the x-axis. All right, so this is input and this is output. But actually, you know what? No, let's look at it like this. Let's run this back because I kind of feel a rant coming on because I'm not a fan of the way they did this, but it's the same thing, okay? So we although we have the actually, no, this is still input and output, okay? So her input is the distance, right? But of course, the further she go, if she's running around the track, then the time extends based upon how far she is from the starting point, okay? So that's why you have this graph that looks like this. So this is our starting, but it says, what was her furthest distance from the starting point? Now, we know this is the starting point. Why? Because the time is 0. When she begins, the time is nothing, okay? So it says, what was her furthest distance from her starting point? Well, let's look at the distance. Boom, it's right here, all right? And as you can see, the scale is by 25. So 25, 50, 75, 100, 125, 150, 175. So if we add 25 to this, this will be 200. So 200 meters. All right. Estimate how long it took her to run around the track. Well, let's look at this. What is the highest time? So boom, this is the highest time. So now the scale up here is by 12s, right? So let's just say this would be 84 here, and then halfway between that 72 and 84. So half of 12 is 6. So this would be 78 there. So roughly around, I would say roughly around like 74, maybe 75 at the most. So I say 74 seconds. Okay, just make sure you don't have anything higher than 78, because remember, 78 is halfway there. So I would say anywhere from 74, 75 seconds is what it took. Estimate when she was 100 meters from her starting point. Well, when she was 100 meters from her starting point. Boom, right there. Let's look at the time over here on the left. Boom, it's about halfway. So I'm going to say about 18 seconds. Okay. And it asks us, how do we know that? Okay. So it's a couple things. We can estimate it, because if you look here, if you draw this line from this point here, then boom, it's halfway between the 12 and 24, which is 18. All right. Estimate how far she was from the starting line after 60 seconds. All right, so when our time is 60 seconds, so boom. All right, so 60 seconds up here. So let's look down, look at the distance. 75 meters. 75 meters. All right. And once again, it says, how do you know? Well, we look up at the time and see 60 seconds, and then look to the right, see where does it touch the graph. All right, so we start here, and then we just look to the right there. Boom, 75. All right. Last but not least, what does the point 150, 48 represent? 150 and 48. So 150 and 48 represent Priya. Notice the X coordinate is the distance, the Y coordinate is the time. So Priya was 150 meters from the starting point after 48 seconds, because the Y value is the the Y value is the time. Okay, so that's what that point says. All right, so this is the other bridge. Now let's get into the next part of this lesson, and these are actually, let's see, let's stop this, let's stop sharing, let's pick up my other activity one. Boom. All right, and I'm going to share my screen again. Activity one. So it says, for each situation, draw a graph that could represent it. Okay. Now, your graph may not be exactly like mine, but I want you to see some examples. It says Diego starts at home and walks away from home at a steady rate of 3 miles per hour. Let's look at this from a perspective of points on a plane and the different parts of that. So he starts at home. Okay, so he starts at home. He walks at a steady rate of 3 miles per hour. Okay, so that rate stays the same. So notice on the y-axis, we have the distance from home. So if he starts at home, his distance from home is 0. And then this is the time in hours. 3 miles per hour. So that's telling me that, so this is telling me two things. This is telling me we have a y-intercept of 0, 0. And this is also telling me we have a slope of 3 miles an hour. Okay, so if I start at 0, 0, how can I show 3 miles per hour? Okay, so let's go up 3 and over, all the way over here to 1. We go up 3 again. And over to 2. And then boom, we just connect those with a line. All right, we just connect them with the line. Boom, there it is. All right, we're going to do a different color for the second one. So May starts 5 miles from home. So May starts 5 miles from home. And walks at a steady rate of 3 miles per hour towards her home. That's important. And then she gets there and stays, okay? So if she starts, so this basically says the y-intercept here is 5. The distance from home is on the y-axis here again. All right, let me erase that. So 5 miles from home, she's starting right there. And then she walks at a steady pace, steady rate of 3 miles per hour from her home. So boom, we want to say 1, 2, 3. and then over 1. Boom. 1, 2, 3, over 1. So I could put this point down here, but of course that's off the graph. I saw 2 students arguing about this earlier. It was pretty cool though. So boom, there you go. All right. So that's what the graph looks like. Of course, this part that extends beyond the x-axis is not necessary, but it's used for a point of reference. Okay. So those are pretty simple. Notice I didn't write here the we have 0, 5, and we have m equals -3. Why is it -3? Because it's talking about she's walking towards her home, so her distance from her house is decreasing as she gets closer to the crib. All right, clear these out. Let's get another one. And share this. A soccer player kicks a ball that's on the ground so that it goes up to a height of about 10 feet, and then it comes back down to hit the ground 1.55 seconds later. Now, you know that the path of a ball is going to go up and comes back down because of gravity. So we know this is going to be some kind of curve. It's not going to be a straight line. But the thing is it starts on the ground. Okay? So it starts on the ground. It's on the ground. That's important. So boom, it's here. Once again, the height above the ground is on the y-axis. The time is on the x-axis. These details are important. Read the graphs. So it goes up to about a height of 10 feet. All right, so it goes up to a height of 10 feet, comes back down to hit the ground 1.55 seconds later. All right, so boom, it's going to hit the ground again about right here. All right, because remember, if this is 1, so this is 0.25, 0.50, 0.75, 1, 1.25, 1.5, 1.75, and then 2. So boom, this is where the graph hit the ground. Now, it went up to a height of about 10 feet. Where's that 10 feet at? Boom, so it's halfway in the middle. So somewhere around here, right? And so then we just draw this. Now, it's not going to be perfect, but it's going to go up in the sky like that. Touch that 10 feet. And then it's going to come down like that. Now, yours could be a little more curved. Mine's not perfect, but you get the idea. You get the gist of that. So that's what it looks like, okay? I think this graph is kind of lazy. My hands are shaking, obviously. But you see, you get the point. All right, so that's that. I think there might be one more. This last one is pretty cool. And actually, I might, this last one is pretty cool. I might do this one and stop here. We'll see. It depends on how I feel. Let's stop this share. Let's pull up the next one. What I like about this one is left for a little bit of interpretation. So I'm gonna draw 2 different versions of this one. And why is it not sharing? This one looks like this, right? So notice it says the amount of charge left in a phone battery as a percentage is a function of time. Claire runs her phone until it's completely dead, then charges it all the way back up at a steady rate. Okay, so it doesn't say whether her phone was 100% charged. It doesn't say how much charge was left in her phone. So let's just say, let's pick a number. Let's say Claire had 60% left in her phone, right? And she ran it until it was completely dead. So let's say it took her, let's say roughly 7 hours for her phone to, or no, let's 9 hours. Let's say it took her 9 hours for her phone to run out 60%, and then she charged it all the way back up. Now, do you think does it take as long for you to kill your battery on your phone? We're not talking about the old phones. Like if you have a really good phone, new phone, it's going to take a lot less time to charge it up. And then if you have the HB, what is it? The C, whatever, the cord that looks like this. I forgot what it's called. Where's my camera? I forgot what these are called, but y'all know. USB-C, that's what it's called. USB-C camera. If you have one of those or USB-C charger, they charge your iPhones really fast. So we're gonna say it took her roughly 3 hours to charge her phone. Boom, it's back at 100%. So this one, if we connect these lines, then it could look like this. Now, your graph doesn't have to look exactly like this. It could look a little different. All right, so then boom. That's what that graph would look like. And what we're saying is, as you can see, it took about 9 hours for her charge to go from 60% to dead, right? But it only took about 3 hours for her to charge her phone back up to 100%. We could do a different version of this. Let's draw a different color. Let's say let's go green. Let's say her phone was at 100% when she started. All right. So it can start right here. And let's say it took, in this case, 18 hours for her phone to run out. But it still may only take about 3 hours for her phone to charge. It may not take as long. Let's say it takes a little long, since we said 3 hours to charge. Well, no, still gonna take 3 hours, same amount of time, basically. Okay. So boom, we could say here it goes from 100%, and then here, boom, it charges back up. All right. So your graph doesn't have to look exactly like my graphs in activity 1. Your graphs may look a little different. That's totally fine. But just remember that when you look at these graphs, think about the context. Make sure you are reading the information that's on the independent axis, which the x-axis. Look at what's on the y-axis as well. So think about inputs and outputs. Sometimes you may see a problem where they switch it up. So you got to read the problem, the context. What is a function of what? Okay. And then you got to read the graphs. If you have to create a graph, you need to label it. Your independent variable is going to be on your x-axis, your input. Your dependent variable is going to be on your y-axis, your output, things like that. Okay. Pause this, rewind it, do what you got to do. But make sure you write the information down in your workbook. And if you have any questions, you can type them in you can send them to Canvas. You can send them on the YouTube video link or whatnot. And I will answer those questions. Remember, good leaders ask great questions. And so that's the end of this party. Deuces. Let's try to turn this off.